Okay, fourth grade, welcome to lesson 6-7. This is page 206. We're going to be working with more partial quotients division. So this will not be a new concept. It's going to be a continuation of a concept we introduced a few lessons ago. And usually when you see lessons like this pop up, where it's just more of something we already learned, that's the book's way of saying this is really important and we know you need more practice. If you worked hard on the last partial quotients division and it didn't totally click, that's okay. That's why we're practicing more today. Okay, so let's dive right in. I'm going to walk you through some strategies, or mostly just review of how we use partial quotient division. So it tells us to estimate and write a number model to represent the problem, and then use partial quotients to solve. You know, one of my biggest problems with math, one of my personal issues, is I always forget to estimate. I'm going to try to make a point to follow those rules today. So let's start by estimating number one. And it tells us there's 184 plants to put into pots. And each pot can hold 8 plants. So how many pots are needed? And I know here this is going to be a situation where we're going to have to take 184 plants and divide them into groups of 8 because each pot can only hold 8 plants. So we need to figure out how many pots we actually need. So maybe I will start with my number model first, which I know is going to be 184 plants divided into groups of 8. I'm just going to use X. X is my go-to when I'm not feeling creative for other variables. Now let's talk about estimating. If this is my number model, what can I round these numbers to that would be super clean and easy to work with when we're talking about mental division? I see this 184 and my first thought is, hey, that's pretty close to 200. And some of you might say it's even closer to 180 or even 190. Maybe 180 is easy for you to work with when we're talking division. It's really not for me in most cases. 200 is way easier for me to work with. So I'm going to go all the way up to 200. And when I look at the 8, 8's really close to 10. And I know when I'm talking about addition, subtraction, multiplication, or division, working with tens, that's one of the easiest or best things for me. So I'm going to go ahead and divide by 10. And so now the question is, what's 200 divided by 10? And I know 10 goes into 100 10 times. So that means 10 must go into 200 20 times. So again, estimating should be something we can crank out pretty quickly. If we're spending 5 to 10 minutes estimating, that probably means we need to rethink our estimation strategy. Okay, they don't want you to sweat over estimates. They just want a general guideline so we know when we get our final answer, are we close to our estimate? And that can tell us whether we did the problem correct or close to correctly. So let's start tackling this problem with partial quotients division. Here's the setup. And, before I get a chance to write it, it would be helpful if maybe you paused and you tried to set this up on your own before you watch me. But if you're totally lost and you can't remember anything, here we go. Our division problem is going to look like this to begin. And for your parents or guardians, this will look familiar at first because this is how we all learned it in school. We learned traditional division, and we know this whole thing. This would be the start of what would usually be called long division, which we will introduce. But for now, we're going to take a turn. This is where your parents and guardians might not be quite as familiar. We're going to take a line and run it straight down here like this, almost like a flagpole. And now it's our turn to start taking chunks of 8 out of 184. Okay, so we want to think of a multiple of 8 that will help us take a big chunk out of 184. For instance, I know 8 times 10 equals 80, so we could take a big chunk of 80 off of this number. But today, I'm going to challenge you because I know you guys are pretty great with your multiples and multiplication. So I'm not going to say 8 times 10. I'm going to say, can we go 1 10 higher than that? Can we do 8 times 20? Okay, can we do that? Let's try it. What's 8 times 2? 16. Add a 0. 160. So 80 takes off a pretty big chunk, but 160 takes an even bigger chunk off. So if you're feeling solid about multiplying 8s by 10s, we can start with just, let's take a multiple of 20 off. 8 times 20 is 160, and I'm going to put that 160 right in here. And do you guys remember what we do with these two numbers now? We need to subtract them. 4 minus 0 is 4. 8 minus 6 is 2. 1 minus 1 is 0. We don't need to show him. So now we have 24 left. And since I'm feeling pretty good about my multiples of 8, the question's going to be, can 8 go into 24 cleanly? And if so, how many times? And I know there's a relationship between 8 and 24. And in fact, I know 8 times 3 will equal 24 right on the dot. So in that case, I'm going to use 3 as my multiple. I'm going to make sure he's in my ones place right here. 8 times 3 equals 24. And we're going to do the same thing we did the first time. We're going to subtract those two numbers. And what are we left with? 0. We have nothing left to divide. That means we're ready for the final step, the fun step, the cleanup. We're going to take anything, any multiples we used over here, we're going to add them together. 0 plus 3 equals 3. Make sure your place values are lined up. You don't want this guy in the tens place, or else you'll end up with 50 instead of the real answer of 23. So how many pots did we actually need? We needed 23. And to bring it full circle, this is why we estimate. Our answer is 23, so we can look back at our estimate of 20 and we can ask ourselves, all right, do we think our answer makes sense? Is 23 pretty close to 20? Yeah, 100%. The real problem would come in if our answer was something like 50, or if it was 230. 230 would be way far removed from our estimate, and that should send off alarm bells in our head. But instead, our answer and our estimate matches up pretty well. That tells us, hey, we may have just about nailed this. Now, I do want to show you one other thing for my people who maybe, maybe I'll say this. If this feels good, if this feels sharp, if you feel like you're ready to move on, I say go for it. Go to number 2, give it a go. But for my people who are like, 8 times 20, that's crazy. I don't know what's going on there. You don't have to do these big numbers. I'm going to make a little squiggly. I'm going to show you an alternate route you could go. If you're not feeling good with multiplying 8s times large multiples, let's say you only wanted to do 10 at a time. Let's say 8 times 10 equals 80. That means you can put a 10 here, put the 80 inside, subtract the 104, and you might recognize, hey, can we do 80 again? Yeah, we can. So 8 times another 10 would be another 80. Subtract. 4 times 0 is 4. 0 minus 8 we can't do, so we have to borrow 24. And then we're left in the same position we were on this side. How many times does 8 go in the 24? I know 3 times, so 8 times 3 equals 24. You've got nothing left, so it's time to add. 10 plus 10 plus 3. I know 10 plus 10 is 20, plus 3 more equals 23, which matches what we got over here, what we got here, and what we have here. So long story short, there's multiple ways to do partial quotients division. You can use any numbers that you feel comfortable with. I'll tell you, the bigger numbers you use, if you're someone who can do 8 times 20, you're going to have a shorter amount of work. It's only going to be, a couple of multiples. But if you need to do by tens or even less, it's still going to get you to the right answer. It might just be another couple rows in some cases before you get to that answer. You'll notice we're adding 3 numbers up here and just 2 here. But as long as you're doing your multiples correctly, you're going to come out to the same answer. I'm looking at the time. Looks like we're at over 11 minutes. Maybe I'll show you a setup for number 2, but I'm not going to do it for you, I don't think. The carpenters are installing hinges. They have 371 screws, and each hinge needs 3 screws. So hinges are typically used for doors or cabinets, and you need to screw those in to make sure the doors and the cabinets can actually open. Each one of these needs 3 screws. So the question is going to be, how many hinges can they install if they have this many screws? 371. So just like number 1, it's going to be division, guys. 371 screws divided by 3, because every hinge needs 3 screws. And maybe I'll use an H as my unknown. So real quick, I'll throw an estimate at you. I would probably round this up to 400. I'd round to 3. I know we've been working with tens, but in this case, I might challenge you and say, how about, what if you did 5? And I'll tell you, the trick for our division here is going to be, can you do 40 divided by 5? Okay, and if you can do that, all you have to do is add a 0 to your answer to get the actual estimate. So 5 times what equals 40, and then add a 0, and that will be your estimate. And the actual setup to the problem will look like this. Starts out by looking like the old school long division, but then we take a turn. We're going to make a long line. And the first question you're going to ask yourself, what can I multiply 3 by to get me really close, or just at least pretty close, to 371? Is there something that you can multiply in your head times 3 that can get us pretty far up there? And again, my hint, think of tens. Think of powers of 10, or even in this case, you can think of hundreds. So put that in mind, and that could give you a great head start on number 2. If you have more questions about the process, again, you can either rewatch, you can message me, or you can YouTube. Partial quotients division is a pretty popular concept, which means there's a lot of videos out there that will help you out. And in fact, a lot of videos that will be shorter than this one, because they're not going to walk you through a journal page. They're just going to teach you how to partial quotient divide. So there's a lot of things you can do to learn more, but I want you guys to go ahead, try pages 206, 207, see how it goes, and I'll see you for 6-8.